Okay guys, it's me Imad. So today in this video tutorial we will learn about how to use a multiplexer within the simulide simulator. Okay, now in order to use our multiplexer we need to search for mux in the search components box. So we will write mux here and we got our multiplexer here. So we will click on this mux and drag it out to the main window. Now you can see that it is actually an 8-to-1 multiplexer and it will be controlled with the help of these three select lines. But we can double click on it, we can reduce its size to 2 bits. That is the address size in order to make it simple. Now there are 4 inputs and 1 output. And there is another output which is actually the inverted form of the original output. And with the help of these two select lines, that is S0 and S1, we can control the data flowing from inputs to the output. Means that we can apply certain logical combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1 on these select lines. Okay. And whenever we will give a logic of 0, 0, then our D0 data will be sent to the output. And when our logic combination is 0 and 1, then D1 data will be sent to Y, our output. When it is 1, 0, then D2, and when it is 1, 1, it is D3 data that is being sent to the output. So now let's try this simulation. So we will go and we will take fixed voltage power supplies here. So this fixed voltage power supply will actually give a logic 0 or logic 1. Okay, we will copy it out and we will paste it out. Copy and paste. Copy and paste. Okay. Okay, now all of the data input lines are being connected with data power supplies. We will go and we will, okay, now we can also click on this select to fit or zoom to fit. So now these are our select lines. One more, I place it here. Again click on zoom to fit and now this is like this. So now we will connect our S1 with the power supply, S0 with the logic, or logic we can also say logic supply because it will provide 0 and 1. Now on the output we will use our LED. So LED, yellow color LED, we will try. Now we will drag it out like this. And we are not using this Y dash and this enable pin. No need to use it because it is by default enabled with the help of this bubble. Okay, and Y dash we are not supposed to use it because it is just the inverted form of our output. Okay, we also need to take resistor so that our LED is not going to burn. Rotate counterclockwise or in any direction because resistors don't have any sort of polarity. We will go and we will connect it with the ground. Now after it, you must listen how it used to work. So now you can, okay, wait, let me see what is the problem here. Like this, okay. Now we run it out. Now you can see that our logic on S0 and S1 is 0, 0. So now you can see that by giving some data on D1, D2 or D3, nothing is flowing to the output. But whenever we will, because now with the help of these select lines, we have selected D0. And now D0 data must be on the output. So it is, you can see that LED is blinking as according to the data supplied by D0. Now we will apply 0, 1. Okay, 0 1. Now you can see that D0 data is not going to the output, but okay, wait, let me see, because it is sometimes okay, we can apply 0 1 like this, 0 and 1. So now our data is flowing. They are actually considering S1 as first and S0 as second, like logic combination wise. Okay, so now data is flowing from D1 to LED. And what about D2, D3? Nothing is going to work. Now we will go for 1 and 0. So it is 1 and 0. Now our third line data has been gone to the output. And now what about fourth one? If we applied 1 1, then only 4 data input data has been sent to the output. Now you can see. So we can say that fourth one multiplexer is also called as the data line selector. And with the help of these two select lines, S0 and S1, we can control the flow of the data to the output. So in this way, we can simulate a 4:1 multiplexer within the simulide simulator. So thanks for visiting our channel, and don't forget to subscribe.